Hi, this is designed to be a quick review video of implicit differentiation for the BC class. If this was my instruction for the first time you've seen implicit differentiation, I would be a failure. So I'm going to go fast. Here's a pretty ugly looking equation, and we want to find the slope of this thing at x equals 0. Since it doesn't seem very reasonable to make this into a y equals equation, we have to use implicit differentiation. So when I do that, I'm doing the derivative of each term and tacking on some good Leibniz symbolism. The derivative of 3y squared is 6y, and I just took the derivative of the y term, so dy dx. Now when I get to this piece, this is product rule. So the derivative of the first piece is 4, and I just took the derivative of an x term with respect to x. So derivative of the first times the second plus the first times the derivative of the second. The derivative of the y is a 1, and I just took the derivative of a y term with respect to x. So these little pesky symbols are what you need to remember when you're doing implicit differentiation. And by the way, when I took the derivative of 4x and got 4, I wrote dx dx, but remember dx dx ends up simplifying to 1, so technically you can skip that and you haven't done anything wrong. Side note, the derivative of 48 is a 0. There's no symbolism to put there, and even if there was, 0 times any symbolism is still going to be 0. So once you've done that entire first step, your job now is to go through and solve for dy dx. So everything you're seeing in these following steps, let me raise that up, everything you're seeing until here is algebra. Ugly algebra, but it's algebra. So now remember that the request was to find the slope at x equals 0. So dy dx gives me the formula for the slope at any point I care about. And so you would say, well, let's plug a 0 into there. Here's your problem. This formula for the slope, this derivative, needs x values and y values, and we just know the x value. So here's how you fix that. You take that x equals 0, and you go back to your original equation, and you plug in x equals 0. When you do that, you're going to have a y value that you can solve for. So this equation, putting an x equals 0 in there, now looks like this. I solve for y, so I know my y value is plus or minus 4. For the sake of simplicity, I'm just going to use the plus 4, but you can investigate the minus 4 if you'd like. So now when I plug into my derivative, an x equals 0, y equals 4, I get a 2/3, which tells me the slope of that big ugly function from the very, very top of the paper is 2/3 when the x value is 0. That's your quick review of implicit differentiation.